Hello students, in this video we'll discuss about regression. What is regression? Regression is a statistical technique which is used to model the predictive relationship between a dependent variable and independent variable. And even this regression, it is a supervised learning technique. And here, this regression, it follows a statistical technique to model a predictive relationship between several independent variables and one dependent variable. The objective of this regression is to find the best fitting curve for a dependent variable in a multidimensional space, with each independent variable being a dimension. Suppose if we have one dependent and one independent variable, we can plot the data points in a two-dimensional space. If I have more than one independent variable, right, assume if you have two independent variable and one dependent variable, we need a three-dimensional space. That's what they have given here. The objective is to find the best fitting curve for a dependent variable in a multi-dimensional space. And the quality of fit of the curve, the data can be measured by a coefficient of correlation, which is denoted by small r and which is calculated as a square root of amount of variance explained by the curve. And here, these are the steps for the regression. First, I have to list all the variables available for making the model. What is regression? I have to make the model predicting the relationship between the dependent and independent variable. Then you have to establish a dependent variable and just visualize it and check whether you could get a relationship between the dependent and independent variable. If not, if you couldn't visualize and understand the relationship between the dependent and independent variable, you have to predict the predict dependent variable using the other variables. Right? You have to predict the value of the dependent variable using other variables. So these are the steps under regression. Coming to correlations and relationship, the statistical relationship are about which elements of data hang together and which ones hang separately. So when there is some similarity between the data, it will be in the same group or it won't be in the same group. It will be in a different group. So when there is some relationship or some similarity between the variables, right, they will be put together in a single group. So it is about categorizing variables that have a relationship with one another and categorizing variables that are distinct and unrelated to other variables. And the strength of this correlation is a quantitative measure that is measured in a normalized range between 0 and 1. So as I said, regression, I have to model the predictive relationship. Regression is a technique to model the predictive relationship between two variables. And if I want to measure the strength of this relationship, I'll go for this correlations. Correlation is measuring the strength of the relationship between a dependent and independent variable. And the range of this correlation is 0 to 1. If the range is 0, there is no relationship between the variable. If the range is 1, there is a strong or perfect relationship between both the variables. So to measure the strength of the relationship between the variables, I am using this correlation. So correlation is measuring the strength of the variable, strength of the relationship between the variables. Correlation is measuring the strength of the relationship between the variables. And as you can see, the relationship can be positive or it can be an inverse relationship. I'll show you a graph. You take this graph, take the first one, take this graph. So you have only two dimensions, x and y. See here, this is my first data point. So the value of x is a minimum, almost minimum. Similarly, y also, it is somewhere here. Next value of x is here and next is y is somewhere here. So you can see as x increases, this y also it increases. Y also it increases. As x increases, y increases. Right. If you find the best fitting curve for this plot, it should be a straight line. Right. The best fitting curve, it should be a straight line. So this I'm saying is positive relationship. Positive relationship means both will be traveling in the same direction. Either both will be increasing or both will be decreasing, but it travels in the same direction. See the next graph. See this one. Here, this is my x. This is my first data point. X value is almost minimum, and y value is almost maximum. Next data point x it increases, right? Y here it is increasing again. For the next data point x increases, y decreases, x increases, y decreases. You check, as x increases, y is decreasing. As x increases, y is decreasing. Right, so this is an example for inverse relationship. In inverse relationship, one it will be in the increasing mode, other it will be in the decreasing mode. Right, so if you find the best fitting curve for this, it will be a straight line only, but it is inverse relationship. That's what it is given here. The relationship can be a positive or it can be an inverse one. If it travels in the same direction, it is a positive one. If it travels in the uh, if both the data points travel in different direction, it is inverse relationship. And a good measure of correlation is the correlation coefficient. You know, correlation coefficient, it is denoted by small r, and the range of this small r is -1 to +1. -1 means it is inverse relationship, +1 means it is positive relationship, 0 means no relationship. And this is a formula to calculate this coefficient of correlation, which is denoted by small r, which is equal to x minus x bar into y minus y bar root of x minus x bar the whole square into y minus y bar the whole square. This x bar and y bar are the mean. Mean is nothing but average, right? Average of x, average of y. And next we can see this graph. Visually we can look at these graphs. Here this first two graphs I have explained just now. X increases, y increases. So the best fitting curve, it will be a straight line. So it is known as linear relationship. And this relationship is linear as well as positive. Positive relationship, as both are traveling in the same direction, it is a positive relationship. Next is as x increases, y decreases, so it is inverse relationship. And here if you see the best fitting curve, it can be it is a straight line, so it is known as linear, but it is inverse relationship. Next you see this, as x increases, y it decreases. Y it decreases, so it is inverse. And next if you see the best fitting curve for this, it don't be a straight line, it is just a arc. You can see it is a curve, right? This is the best fitting curve, so it is known as curvilinear relationship. Curvilinear relationship, curvilinear inverse relationship, right? Next you see this, as x increases, y also it increases, so it is a positive relationship. And here if you see the best fitting curve, it is an arc. It is not a straight line, it is an arc, so it is not linear, it is curvilinear. Curvilinear positive relationship. Now check these data points. I could not find any relationship between x and y, so no relationship. For these data points also no relationship. And in the next exercise we can discuss some sums. Thank you.